because different threads will execute from the runtime system. So the user level threads, you have thread table in the user space, right? And the kernel level threads, we have thread table in the kernel space. So that was the difference. So I asked you to go through the advantages and disadvantages. So let's go to so today we go to lesson 7, 7th lesson. So you can see the screen now. Is it clear, readable?
Yes, sir. Yes.
Okay. So we have scheduler activation and pop-up threads. So here you have to learn what is scheduler. Schedule different items, different threads, different processes, and so on. Then the pop-up threads is the the pop-up screens. Time to time we get when we run something, the pop-up menus, right? When there's an error or something, or if you need to select some option, you get message box like thing. Different times. For example, when you are copying files, sometimes you get pop-up message telling this is already existing. Do you want to copy, skip, or replace, or have a different copy and like that, different options. So that is pop-up menus, right? So today we'll talk about scheduler and pop-up threads. Now I think you know the difference between processors and the threads. One process can have many threads. So sometimes we call them lightweight processors. So same process can have many different threads which can be executed on the CPU processor, right? So just to differentiate, I call that SOR1 processor, right? But normally we pronounce as processor, but now we have different process, software one and the hardware process. The hardware one we call processor, right? SOR. Here SES process, software part, the execution, programming execution. So the process can have different threads. Now, in the previous lesson, we have discussed about threads. In this lesson, we are going to talk about the concept behind scheduler activation. So scheduler is like a manager who decides which one to run, which one to stop, and so on. So our operating system, we need such kind of, so in this case, it is not a human being, but a part of your operating system program, right? In this lesson, we are going to talk about concept behind scheduler activation. In addition, you will be able to explain the functionality of pop-up threads. So learning outcomes after completion of this lesson, you will be able to identify the concept behind scheduler activation. So in operating system, you have to write a program called scheduler activation. So we will learn about it. In addition, you will be able to explain the functionality of pop-up threads. Therefore, the lesson would enable you to explain the concept behind scheduler activation. Also list down advantages and disadvantages of having pop-up threads. So what is this scheduler? This concept is presented by a person, developed by a person called Anderson in 1992. So this multi-threading concepts operating systems came after like version and so on. So the scheduler activation presented by this person Anderson 92. The goal of scheduler activation is to have the functionality of kernel level threads. Now you should know what is kernel level threads. And in combination with the better performance and flexibility of the other thread, user level thread. So it's kind of combining. Why? To have better performance and flexibility. So to improve the performance and flexibility of our operating system, we can use this concept called scheduler activation. Therefore, when this method is implemented, there would not be a necessity of making non-blocking system calls to check if a particular call is safe. So normally when we make a call, if it is non-blocking means others cannot block it once call, right? So to avoid some problems, like you have learned the deadlock situation and so on, right? If someone is waiting for an event but it is not happening, and our computer system might get stuck, cannot continue. So to avoid that, one solution we use is non-blocking system calls, so no one else can block. When there are non-blocking calls, if no one can stop that, there can be sometimes issues like waiting for that. Right? To avoid that, scheduler activation can be used. Non-blocking system calls the problem. Another problem is when a page fault occurs, it will be possible to run other threads within the same process. So this one we have not explained what a page fault is. Page fault is like now when you run a program, sometimes you can't load all of your program to the computer. Sometimes you can't load whole program to the computer. Means where do you load program from hard disk to your main memory? Because of memory restrictions, when there are so many programs running, we can't load everything into the main memory. Okay.
Excuse me, sir. Sir?
Yes.
One student is waiting for the classroom.
I can't see anyone waiting. Okay. Let's see. Join again. Right now, I can't see anyone waiting.
Okay, I will check.
Right. Okay. Now, when a program or thread is running, it is checking required information from the main memory. So since we cannot load everything from hard disk to main memory, there's a way of loading. The way of loading is page by page, right? Maybe if you can keep only 5 pages at a given time, you load. So initially you can load 5 pages, but later your program sometimes you have loops going into different places, right? So if the reference one is not in the memory, we call it as a page fault, right? So you may learn this concept in other module, but the page fault is something like that. So hope you got the idea. So when you load page-wise from hard disk to memory, if the required page is not available, it is called page fault. It's it can slow down computer, affecting the performance. So this concept is introduced for better performance and to have better flexibility, right? So two problems is, one is to avoid the problems occurring when non-blocking calls are there. Second one is to problems occurring when page faults, right? So those can slow down the system, that means affecting the performance. So this schedule activation is to address some of those. Right? So when a page fault occurs, it will be possible to run other threads within the same process. So when we have many threads in the same process, if one thread cannot run because of a page fault, we can run another thread until that page gets loaded, like that. But we need the scheduler activation to do that. The main technique used to achieve efficiency is to reduce unnecessary transitions between the user space and the kernel. So when there are so many transitions, now where we got transitions, you should remember that state diagram, the two models we talked, 2-state model and 5-state model. So different states, running state to wait state, there's a transition like that. So when there are so many transitions, it will slow down the system, reduce efficiency. Therefore, we need to reduce number of transitions between the user space and kernel. Because each transition you have to pass different data into different places and so on. So when a thread blocks, in case running thread these blocks, the user space runtime has the ability to block the synchronizing thread and schedule a new thread. So how do you do that? How can we do that? So when a schedule activation is used, initially the number of virtual process core. Now you have to note the spelling. This case referring to what? This one. This one referring to when you have OR. Is it the software or hardware part? Processor. It is
virtual processor
referring to hardware, no? CPU. Right? So what is meant by virtual processor then?
physical processors.
So the program or the user thinks there are more than one processor, right? Like virtual memory. So more than existing memory, we expand the program things. Let's say you have to make physical memory, but you can have virtual memory to increase it to 4 meg or 8 meg, like that. Not the physical one, virtual, right? Like that, if you have one CPU, you can make virtual processor. So initially, a number of virtual processors are assigned to a process by the kernel. Right? So number of virtual processors are assigned to a process. Process means the running or executing program, right? So program thinks like there are many processors. So different parts of the process or threads can assign to virtual processors, right? So like parallel processing. So you can run different things. So virtually, we think there are many processors. So you can run many programs in parallel, right? So who is doing this? This assigning thing by the kernel. That is the system, right? Initially, a number of virtual processors are assigned to a process by the kernel. Then what will happen? Yes, assigning like that will not implement, right? So next, the user space. Runtime system allocates threads to processors. Now you have many virtual processors. Now user space runtime system allocates threads to each processor for execution. Depending on the requirement, the process can request for extra processors. Process is the program. So sometimes it may request more processors, or sometimes you release assign process, right? Depend on the program. Sometimes you need many processing powers, so request more processors. Sometimes you can release assigned process. Additionally, the kernel can also take back assigned processors. So sometimes kernel interfere and take assigned process for other important one. Okay. Now, I know some of you might face difficulty of understanding this if they are not familiar with these terms now. Right? If you have difficulty, you can ask question. Right? So, because I am reusing the terms which you have learned, like kernel, processor, process. So, if you can't understand, another thing is you have to read previous lectures and also listen the recorded ones. Okay. Because we use new technical terms. Today also you learn few terms like page faults and so on, right? So you have to, if it is new to you, you have to read it again or listen lectures again and again. Okay. Now you should know kernel space and user space, right? So kernel space is mainly referring to system side. User side, we have our own programs and so on, right? So the communication between another person within. So the communication between the kernel and the runtime system is handled using a mechanism called upcall. So this is another term. So you should learn this. When new terms comes, you have to learn those. Even your exam, I may ask what is upcall. Then you have to explain. So the communication between the kernel and the runtime system is handled using a mechanism called upcall. These notifications happen when the kernel activates the runtime system at a non-starting address. So notifications, you can notify. So kernel activates the runtime system at a non-starting address. During an upcall, so when you call this, the communication between kernel and the runtime system handled by upcall. So when you, during an upcall, the parameters on the stack, so it's like a procedure or where you can have many parameters pass. The parameters on the stack, the number of the thread that has caused the interruption, and the description of the event are passed. So when there's interrupt or blocking, right? So which threads cause that? So the number of threads, also the stack parameters, which instructions executing, the history, and so on. So we have talked about stack also last time. If you're not familiar, you have to go back and pass, right? So call, you have to pass these type of parameters when you call that function or the upcall command. When the kernel identifies that a thread has blocked, system identify when there's a blocking, right? The thread has executed a blocking system call, or a page fault has occurred. These are some examples. If there's a page fault, you can't continue the running thing. So thread has blocked. Kernel can detect those things. Okay, system can detect. So when the kernel identifies that a thread has blocked, the kernel. So if we are designing the operating system, if you notice there's a block of executing one. So what to do? So we have to tell the system or the operating system. So during that time, runtime system is activated. Okay, if that happens, the kernel notifies this to the process runtime system one up call. So this is one place where you can use the up call command, right? So kernel notify the blocking to process, runtime process or runtime system, how it has to use subcode with the parameters mentioned above. So when the runtime system is activated, it can reschedule the threads. So if it is blocked, you have to reschedule. It can reschedule the thread by blocking the current thread and activating a new thread from where we get new threads. We have ready list, right? So when you block current one, you have to get a new one from the ready list. So it can activate that process. Okay. How to do that? Afterwards, when the kernel identifies that the originally blocked thread can run once more. So let's say kernel identified one thread is blocked. But later, after a while, it may identify now it can run again. Originally blocked thread can run once more. So what to do when you recognize that? When you identify that, this information is also passed to the runtime system through an upcall. So simply the system or the kernel notify the runtime system. How? Using a call mechanism. Okay. I think you get the idea about upcall command. Once notified the runtime system, it can either restart the block thread or other option is you put it into the ready list. So until that it was in the block list. So once it is ready to execute again, you can either restart it, processing time available, otherwise you can put it in the ready list. Right? Is it clear? Any problems? If a hardware interrupt occurs, let's say some memory fault or hard difficult to read from hard disk, like that, there can be hardware interrupt. Okay. If a hardware interrupt occurs, the CPU switches into kernel mode, right? Kernel mode. That means CPU can inform, okay, I cannot execute this to the runtime system. If the event that has caused the interrupt is not useful to the interrupted process, the state of the process is switched back to the previous stage. So the interrupt is blocked, right? The blocked one is not useful to the interrupted process. So simply you can, the state of the process is switched back to the previous stage. So current one won't execute, but you switch back to previous stage. But if the event is useful to the process, the interrupted thread is suspended. If it is not useful, you can switch back to previous stage. If it is useful, you change the state to suspend. Next, the runtime system is notified. Now the runtime system has the possibility of deciding the thread to schedule on that CPU. So once you suspend, because you need it to run, so when next time system is ready, you can schedule it to run on CPU. For example, the interrupted thread, the new ready thread or any other thread, you have to run on CPU, right? Okay. Now the scheduler activation method combines the advantages of user level threads and kernel level threads. So we have learned those two separately and have seen the advantages and disadvantages. Now this combination of both methods, user level threads and the kernel level threads, how we combine using scheduler activation, right? There we use something called the scheduler activation. Even this new method, there are some objections have arisen against this method. Right? So there are some objections against this method. Since the concept of upcalls violates the inherent structure in layered systems. Layered systems, perhaps you have learned now 7-layer architecture and so on. That layer system, layer n of a services that layers n+1 can call on nearby layers. But layer n cannot call methods in layer n+1. You can't jump 2 layers. But this mechanism of call work against this principle, right? Therefore, there are some objections to implement this method, right? So now you should be able to explain the functionality of a call mechanism, okay? Let's go to next section, that is about pop-up threads. Pop-up threads are new threads that are created depending on a request. As an example, we can consider how incoming requests are handled in a distributed system. So what is distributed system? That means different systems connected together. For example, let's say few of you are editing same document, shared document using different computers. So then it's like a distributed system, right? Then for the document, there can be incoming requests from many users. This just example about distributed system. So processing also can happen in a distributed way. So when there are incoming requests, what will happen? When the traditional thread handling system is used, how can we handle this? A process or a thread is blocked on a receive system call. So when there's a call, incoming request, right? A process or a thread is blocked on a receive system call. Then waiting for an incoming message. Waiting for an incoming message. When the message arrives, what will happen? The currently running thread is blocked and the waiting thread is activated. So one thread is waiting when there's incoming request. So once you receive, so when we are waiting, thread is blocked. The process so thread is blocked, right? Why blocked? Because we have to wait for the incoming request, waiting for incoming message. Okay. When the message arrives, now we are in the ready state. No? Then what will happen? The currently running thread is blocked and the waiting thread is activated. So that's what we need to do. Again, once the activity is completed, the original thread is reactivated and the other thread is blocked. And you understand this. So when there's an incoming request for the running thread, you can't continue it. So you have to put it as blocked one. So when you block something, you can't just keep your CPU idle or not doing anything, right? You have to run another there. Okay. So when you allow another thread to run, you have to block the current one until you get the incoming request. So once you get the request, again this block one can execute, but you have to wait the other thread to run. No, you have to block that and run. So that is the one I explained here. So once the activity is completed, you are giving chance to another thread. No? So once that activity is completed, what we can do is we give the chance to the original thread, which was blocked. Original thread is reactivated and the running one you have to block. Okay. So in this case, you have to switch between two threads. No, you have to block the current one and give chance to another one. Again, the once request received, you have to block the second one and give chance to the original one. So that is some kind of switching between threads. So during thread switching, you have to take care of all values in the registers stack, etc. must be updated and stored, right? Therefore, there is an overhead involved with this thread switching method. So, not only calculating or processing, but switching part additional things. So, it's called overhead. So, when there are so many overheads, your system will slow down, right? It is affecting to the system performance. Okay. In contrast, if pop-up threads are used, so new concept is pop-up threads. Only the arrival of an incoming message causes the system to create a new thread to handle the specific activity. So let's see the diagram. So before the message arrives, you have existing thread in a process executing, right? So when you receive incoming message request, you can create another thread called pop-up thread created to handle the incoming message. So incoming message handled by another thread, not the same thing. So it's like another process. So the thread, lightweight thread. So this is the concept of pop-up thread. Since these are new threads, pop-up threads, they do not have registers, stack values that must be restored. So since it's a new creation, you don't have to restore them, right? Therefore, it is possible to create these threads quickly. So no transitions in creating new one because you don't have to save anything as it's a new one. Therefore, it is possible to create these threads quickly. Thus, the latency between the message arrival and the start of processing is short. So what is this latency means? Latency is the delay or the gap, right, between the message arrival and the start of processing is short. Why? Because you can quickly generate this new pop-up thread. Okay. All the threads created are identical to each other. When pop-up threads are used, some advanced planning is required. If the system supports threads running in the kernel space, remember the two types of threads, user level and kernel level. So some systems support user level threads, some systems support only kernel level threads. So if the system supports threads running in the kernel space, the pop-up threads could be created in the kernel. Otherwise, they could be created in the user space, right? So if system supports user space threads, the new thread can create in user space. If it is not support, we have to use the kernel space to generate this new pop-up thread. Usually creating pop-up threads in the kernel is easier and faster than in the user space. If a pop-up thread is placed in the kernel, it can easily access the kernels like tables and I/O devices. Like to receive new message and so on, you need IO access. So time to time, I'm also getting interrupts when new person trying to get in. So I'm checking this waiting room also. So it is like new incoming message. So I have to handle it separate. It is like creating a new pop-up thread, right? Without your knowledge sometimes. So if a pop-up thread is placed in the kernel, it can easily access the kernel tables IO devices. But on the negative side, if the thread is not properly handled, so it is faster if it is in the kernel. But the disadvantage, negative side, if the thread is not properly handled, a pop-up kernel thread can do more damage than a user space thread. So if problem happened in the user space, it is not affecting to other processes. But if it is happened in the kernel, it is affecting all the processors. No? So it's a disadvantage if there's a problem. But if it is no problems, it's very fast to handle at the system level or the kernel level. Okay. Advantage and disadvantage. Right. So now you can describe the pop-up threads. So what are the advantages, disadvantages, and so on, right? So you have learned new concepts. We have completed lesson 7. In this lesson, we have discussed schedule activation and pop-up threads. So these are new concepts. So when compared to our previous lesson, user level threads, kernel level threads. So new concept called schedule activation can combine these two, right? There you need something called upcall mechanism, the command upcall to combine these two concepts. And the second one we learn about pop-up threads, right? So when there's something like incoming message or something, you can have a pop-up thread, so can speed up the process if you handle it properly. But unfortunately, if something gone wrong, it will affect the whole system when using this pop-up thread concept in kernel level. User level, the damage is not that severe. Okay. Is it clear? You have any questions? If not, we can stop lecture for today. Or do you want me to conduct another one? What do you prefer? Next one is a different topic, inter-process communication. What do you think? Any suggestions? So I think better to be familiar with these concepts first, because inter-process communication, we have to talk that deadlock and those things. Since we have learned new terms, few new terms, I think better for you to go through previous lessons and get familiar with the terms. All right.
Yes, sir. Yes.
Yeah. So for today, we'll stop here.
Okay, sir.
Right. So we'll see